Now, in this section, keeping in the concept of solutions, we want to expand on the terminology of solubility. Solubility in layman language means that how much of a solute can be added in a specific amount of solvent. For example, if you have a cup of water and you start adding sugar to it, you can pretty much see that in the beginning sugar will be added. You can keep on adding sugar to this solution. But eventually you will find that if it's only 1 cup, then it starts getting difficult to dissolve more sugar in it. Now we have then moved from one stage which is called as unsaturated, where you had less amount of solute and more amount of the solvent. And in this situation, it would be called as unsaturated. That is the beginning of your process. And after, when it reaches the maximum amount of solute in that amount of solvent, where it becomes difficult to dissolve, it's called as saturated solution. Now, pretty soon afterwards, you will have undissolved solutes at the bottom, and this would be called as supersaturated. However, supersaturated solutions can also be turned into saturated solutions if you heat this solution up. So one another example of saturation is, for example, honey. If you think of honey that's present in your home, and honey over time, you notice, will start getting thick and settle down in the jar. That's because it's a supersaturated solution by then, and you can get the honey out if you heat it up in a microwave or put it in hot water. So this gives you a hint that heat or temperature has something to do with saturation. And we know that substances can be dissolved at different rates depending if it's a cold or hot medium. Okay, keeping in mind solubility, it's really interesting to see how solubility affects solids, liquids, and gas. I want you to think about it while I'm doing this little graphing over here and show you that solids and liquids, usually you can see here's a solid, and here's another solid, here's another solid, and here's another solid. You can see pretty much all of these are solids, and you can see what for each one of them the graph seems to go higher, except for like sodium chloride. It seems like it's a consistent pattern, but usually solids and liquids will increase solubility as the temperature is increased. So as you increase temperature, the solubility of these two substances or two states of matter will increase. However, gases decrease solubility with increase in temperature. So the solubility is decreasing as the temperature is increasing. In this particular case, solids and liquids also increase solubility. Now, another example of this would be, for example, in very hot situations, you see fish that are dying on rivers or oceans is because the dissolved oxygen, oxygen is a gas and it's present in water, but with increased temperature, the dissolved oxygen escapes out of the river, and when it comes out of the river, there is less concentration of oxygen in the water, and the fish dissolves or die. So gases, on the other hand, do decrease as temperature increases. Another example would be soda can. If you leave the soda cans outside or soda bottles, you know that you get rid of all the fuzz, and there's hardly much taste in your soda pops. Okay. Now, the term solubility was very vague in the previous example. To actually calculate how much of a percentage or how much of a concentration of a solute is present in a given solution, the formula that is used is you take amount of solute divided by the amount of solution. Keep in mind, this is solute and solvent together, times 100 will give you the percentage of that solution. So for example, if I put down 30 grams of solute in 100 grams of solution, you can see that my percentage would be 30%. However, if we took 5 mLs of a solute over a solution, again the same thing, you notice that this also gives me that it's 5% strength. Here is another one. If I put down 47 grams of a solute in 100 ml of solution, again I'm dividing it out and my resulting answer is in solution, is in percentage. All of these we had the same concept in which we took the solute on the top and the total of solute and solvent, or the solution on the bottom. The difference on each was, this was a mass by mass where we have both of the quantities measured in grams. Here was a volume by volume where both the quantities are measured in mLs. And in the last example, which is the most common one, you see grams per ml. So depending on how you are taking each of the calculations, the concept used is the same. That is the amount of solute in the total amount of solution. However, it's important to realize that these concentrations, to get the concentration of solutes for each of these examples, implies that it's kind of difficult to measure, for example, a difference of let's say 30 grams versus 31.2. Now, sometimes experiments are very sensitive, and when you measure slight difference on grams, it should give you a slight percentage of difference in the solution. But sometimes it's very hard to express these percentage and to actually see the difference of these solubilities in reactions. So for this reason, we will learn of another concept which is called as molarity. So we'll learn about molarity in a little while. Here is another example of calculating percentage solutions. As you can see over here, if you have grams of potassium chloride in a solution of potassium chloride, if the gram of sodium chloride is 8 and the water added is 42, now the total solution is 50, which is written over here, the total solution taken over by 8 solute on the top, and you get your answer, which is 16%. These examples are fairly simple to understand, so I'm not going to go too much into it. However, it's important to get to the next step, which is the molarity. But before we go on, let's just do one more two examples, since I did put down some couple of examples over here. So here is another word problem. Now, in word problems, I've noticed the students have difficulty in deciphering what is being asked. So over here, let's see how many grams of sodium chloride are needed to prepare 225 grams of a 10% mass by mass solution. So first, whenever you read these questions, try to break the question in such a way so you know what is given to you. Now, what's given to us is 225 grams of a solution. That's information. That is the total solution, and this solution is 10% mass by mass sodium chloride. So that means it's a 10% solution of sodium chloride. What is needed, what is trying to find out, is the grams. So pretty much, if I go back to my problem, I had solute over solution times 100. So you can see what is given over here. You have the solution, which is this one, and you know that it's a 10% solution. So what are we trying to find out is the grams of the solution. So setting again, now we are learning back to how we did with dimension analysis. You always start with what's given. So we're trying to find out 225 grams of solutions will give you how many grams of solute. So looking at this information, we find out that 250 grams of solution is being solved for, is giving us, it's a 10%, which means that it's going to be 10 grams of solute in 250 grams of solution. So this is the equality that we are now going to use. So keeping in mind, we've got I need to fix something over here. I just realized I was been working with 250, and some of you might be getting confused. It's actually 225. So coming back over here, we start off with a 225 gram solution. Each of these substance is a 10% solution, which means that it's 10 grams of solute divided by 100 of the solution. So this is the information that's coming from the 10% that's given to me. So now we have solution over here. Notice I put solution over here and the salt on the top, which gives me 22.5 grams. So here I am applying the problems that I learned how to use dimensional analysis in the first week of class. Okay, so here is another problem that I want you to think about how to do it. A solution is prepared by mixing 15 grams of sodium carbonate and 235 grams of water. Calculate the mass percent of the solution. So again, what is it asking? This one is giving you the solution, the solute over solution times 100 is my formula. So 15 grams of sodium carbonate plus 235 grams of water, which would be the solution total. And this comes out to be 250 grams is the total. So what is the percentage of this solution? Which is the solute out of these two? You can see the solute is 15 grams over here. So then now the rest would be just multiplication and division to get the answer to this one. Here is the answer that is solved in the next slide. You can see over here we did the 250 grams. We come up with 215 on the top and 250 on the bottom times 100, and our problem solved is for 6% solution. So each time whenever you're expressed a percentage solution, for example, if a solution is 35%, then that means it's got 35 grams of solute in a total of 100 grams of solution or 100 ml. Now M to M or M to V, don't get too hung up on this one, because this is mainly to express you if you were to actually make the solution as to how you will go ahead and measure this. So you keep in mind the percentage and the values and go ahead and put those in to get to your answers. Will make the problem a lot simpler to then comprehend.